Hey, welcome back everyone. In chapter 3, we're going to learn about ways to describe our data using numerical measures. So let's get started. So in this video, we're going to cover the first two learning outcomes related to the measures of center and location. We're going to talk about the mean, median, mode, and weighted mean. Then we're also going to learn about percentiles and quartiles. Then we're going to wrap it up and learn how to create a box in Whisker Plot and how to interpret it. Then in the next two videos, we're going to cover topics related to measures of variation, standardizing values using z-scores, and the empirical rule. So if you recall back in chapter 1, we discussed what a parameter is and what a statistic is. So a parameter is some measure that we compute for an entire population, whereas a statistic is a measure that's computed for a particular sample. So here we have the measures of center and location. We have the mean, median, mode, and weighted mean, and we can calculate these measures either from a population or for a sample. So let's start with the mean. A mean is the numerical measure of the center of a set of measures that's calculated by adding up all of the values and then dividing them by the number of values in our data set. So you are calculating the average, which you may have done in other classes or in your everyday life. So you'll notice that we have two formulas, one for the population and one for the sample. They are structured in the same way, except they're using different Greek letters. So this is how you can tell when you're working with a population or when you're working with a sample. So our population mean is denoted by the Greek letter mu. The summation symbol tells us that we're going to add up all of our x's, and then we're going to divide it by our big N, which is our population size. Similarly, for the sample mean, we see the x bar. So we know that that refers to our sample mean. It's a similar process because it also has a summation symbol, which tells us you're going to add up all of your x's, and then we're going to divide by our lowercase n, which means our sample size. So let's go ahead and do a practice problem. Here's a problem from 3.4 from the textbook. So we have the time in seconds that it took 16 cars to exit a parking lot in downtown Cincinnati. The first step is we need to get our sample size. So the sample size is 16, which was given right in the problem, but you could also just count up all the numbers in the table here on the right. So next, we're going to go ahead and compute our sample mean. So here's our formula where it tells us that we must first add up all of these values here in the table, and then we're going to divide by the sample size. So when we add up all of our x's, we get 1873 in the numerator, and then we divide by our sample size of 16, and we get 117.0625 as our sample mean. Next, let's move on to the median. The median is a center value that divides our data array into two halves. We take our data values and we arrange them in numerical order from smallest to largest. So to calculate the median, you also must identify the median index. So the index tells you the position of where our median is within our data set. So here is the formula for the index, where we take 1/2 times lowercase n, which is our sample size. So let's go ahead and walk through the steps to compute the median. The first step is to collect our sample data. The second step is to order it from smallest to largest. The third step is to find the median index, or I. This step will be different depending on whether the median index is an integer. So if the index is not an integer, we're going to round up to the next highest integer, and then the value at that index position in the data is the median. If the index is an integer, then the median is the average of the values at the index position and the index position plus 1. So that might be confusing without an example, so let's walk through that now. So here we'll continue with problem 3.4. It's still our same 16 cars in that parking lot, but now we're going to find the median. So the first thing you want to do is take the data values that you can see on the worksheet, and then you're going to order them from smallest to largest. So once you have sorted your data from smallest number of 51 to our largest of 169, we could then find the median index. You can see the formula here again is the same as before. So we first need the sample size, which is 16 vehicles. So plugging in 16 into the formula, and we get 8 for the median index. So now recall our rule is if our index is an integer, or meaning it's a whole number, you're going to have to find the number at the 8th position, and then the position to the right, meaning 8 plus 1, which is 9. So we can see the numbers in the 8th and 9th position as 125 and 128. So to find our median, we'll take the 125 plus 128 and divide by 2, and we get 126.5. Now let's talk about the mode. So the mode is a number in our dataset that occurs the most frequently. The dataset may not always have a mode, but when it does, we want to find it. So here is an example data that we'll be working with. So at a glance, we can look for the number that appears the most often. Since this is a small dataset, we can look through it and probably pick it out. But in a larger dataset, it may not be this easy. So what we could do is we could sort it like you see here on the right, and then you just count the frequency of each number. So you can see that 20 appears the most often. So therefore, 20 is our mode because it occurs 3 times. Let's talk a little bit about distribution shapes next. So if we look at the center chart right here, this is a symmetrical distribution, and the mean, median, and mode are all equal. This is known as the normal curve. In the examples A and C, where the mean, median, and mode do not equal each other, so they are skewed in a particular direction. You can see in A, this is a negatively skewed chart, whereas in C, we have a positively skewed chart. Now, when we look at these 3 measures, the mean is generally used unless we have extreme values or outliers exist. So extreme values are very large or very small numbers that can skew our data. The median is less sensitive to extreme values, so this is the reason why you often hear house values quoted by the median price in your area instead of the average price. Let's also talk about the weighted mean. So sometimes we can't just take a simple average like we did in the prior problem. We would want to use a weighted mean because some of the values have more importance than others. You'll notice that whether you're doing the weighted mean for a population or a sample, it's the same process. There are just different Greek symbols. So the W in the formula represents the weight of our data value, and the X is the actual value that we have. Then we'll divide it by the sum of our weights. So let's talk about the steps to calculate the weighted mean. So the first step is to collect all of our data and to determine the weights you'll assign to each value. Then we're going to multiply our weights by each data value and then add them all up. Then we'll add up all of the weights for all of our values and then divide the 2 numbers to get the weighted mean. Let's walk through an example. So in problem 3.11, the La Costa Corporation operates 5 manufacturing plants in South America. The company tracks the medical costs that are directly attributed to accidents that occur at the plants for each year. The following data shows the medical costs at each plant along with the number of employees who work at each plant. So let's go ahead and calculate the weighted mean. To do this, we're going to multiply our variable of interest, which in this case is the medical cost. This is what we're interested in knowing about. And then the weights are the number of employees. We're going to multiply each of our cost values, or the X's, by the number of employees, which are our weights, or the W's. We'll go ahead and bring that down, and we get these values for each plant. We must add them all up in our numerator. Then in the denominator, these are just the weights, or the number of employees. We're going to add those up as well and then divide the two numbers, and we get $11,213.48. So why would Lacosta want to use a weighted average rather than a simple average of the medical cost? Well, this makes a lot of sense since the plants with more employees more likely would have more medical issues. The weighted average takes this into account with it being weighted by the number of employees versus the simple average of the medical cost of all plants. So let's jump into our next topic, which is percentiles and quartiles. When we're working with percentiles, it is essentially providing you the location of data where if we list P%, these are the values that are less than or equal to this value. Whereas if we do 100 minus P%, this is the data that's greater than or equal to this value. So note that our median is at the 50th percentile, so it's right in the middle. When we talk about quartiles, think quarters. We're taking our data and organizing it into 4 parts. The first quartile means the first 25% of our data. The second quartile is where we got 50% of our data, which is also our median. Then our third quartile means that up to 75% of our data is in the first 3 quartiles. So you can see the relationship between the percentiles and quartiles is quartiles are looking at 3 specific values, 25th, 50th, and 75th percentile, whereas with percentiles you can look at any value anywhere between 0 and 100. So let's walk through the steps to calculate quartiles. So to calculate percentiles and quartiles, it's very similar to what we did with the median. The first step is to sort our data from lowest to highest. Then in step 2, we need to figure out our location index. Then in step 3, recall that if our index is not an integer, meaning it's not a whole number, we round to the next highest integer, and that's the value that we're looking for. If our index is an integer, then you'll look at the value in that position and average it with the next value to the right of it. So let's do an example. We'll use the same problem as before with the 16 cars in our parking lot. This time we're going to be looking for the first quartile. So the first quartile is the 25th percentile. So we'll plug in 25 for Q in the formula. Our N, or sample size, remains the 16 vehicles that we have in our data. We solve for this by taking 25 divided by 100 and then multiply by 16, and we get 4 for our index. Now recall that when our index is an integer, you're going to find the value at the 4th position and average it with the number to the right. So here is my 4th and 5th positions, which is 100 and 101. So we take the average, so I'll take these two numbers and divide by 2, and my first quartile is 100.5. Let's go ahead and do the same for our third quartile, which is 75. The sample size remains 16, and then we could do the same calculation as before, and we get 12. Again, because this is an integer, we find the 12th and 13th numbers in the data. So here are my 12th and 13th values. So we'll average these two by taking 135 plus 139 and then divide by 2, and our third quartile is 137. Let's wrap this up and talk about the box and whisker plot. To construct a box and whisker plot, we're essentially taking everything we've just talked about and visualizing it. Here is our box and whisker plot. The center box here is based off our first and third quartiles. Then the line inside the box, that's our median. And then the whiskers extend to the smallest and larger values within the calculated limits. So for our lower limit, we take our first quartile and subtract 1.5 times the width of our box. To find the upper limit, we'll take the third quartile and we'll add 1.5 times the width of our box. And then our outliers are plotted outside of these calculated limits. So these are our extreme values. So here's an example of a box and whisker plot using some ATM data. So for two ATMs located in the north and south, we've taken the values and calculated the first and third quartiles as well as the median. So with this box plot, we can visually see that the south ATM has greater usage. Well everyone, that wraps up this first video covering measures of center and location. In this next video, we're going to talk about measures of variation.